Good morning, all. Previously, Mano Manoharan, he is a member of our team, used to give this presentation in the previous session. He is on annual leave until 29th of this month. So I'm presenting this information on his behalf. So if there are any questions, please feel free to send it through planning policy email. We'll try our best to respond to your queries. Okay, in terms of the pavement impact assessment, the marginal cost methodology is primarily based on the FAMDIT model, depending upon the pavement type, traffic volume, etc. So that's what has been used in the Guide to Traffic Impact Assessment. So I'll run through some of the information which are used in the guide in terms of the pavement impact assessment. Okay, that, as I said, so this is the methodology which is in the guideline. It's primarily called marginal cost methodology. Now, in terms of the methodology, we are using FAMDIT tool, which is Freight Action Mass Limit investigation tool. The ones in terms of the method, marginal cost analysis is done based on the FAMDIT, and then the cost goes into our database, which is called RoadLink database, and then the pavement impact assessment tool is used to calculate the damage as a result of the new developments on the pavement structures. And then the PIA tool, because this is going to be used first time based on this marginal cost methodology, so we'll be providing training to all the relevant staff who are going to be involved in the development assessment activities. Okay, primarily this methodology, there are a number of steps, a number of things we need to be aware of. Now, the main thing is this nationally accepted whole of life cost calculation method, which is based on the FAMDIT. There are a number of technical things we need to be aware of, primarily measuring the road condition data, which is, for example, roughness, rutting, etc., and also the pavement properties in terms of the material, the subgrade and the pavement materials, and also how the road segments will be performing as a result of the traffic impact, and also in terms of the environmental factors as well. We'll be considering those things in the analysis. Recognition of road-specific differences as a result of the traffic volumes depending upon the pavements, and also the result related to physical segments. So each segments which have the deflection data will be considered in the analysis. So we'll be taking into all those segments and then used in the calculation method. So now, what is the time period for the calculation of the marginal cost as a result of the road wear? There are a number of maintenance activities on a segment of a road. For example, routine maintenance, program maintenance, rehabilitation. Just to give a very simple sequence of the maintenance, routine maintenance is done every year. Program maintenance, it varies, say, for example, from ITS to 10 years for reseal, and then goes up to 14, 15 years for asphalt. So let's say in average we go for 10 years, and the rehab normally it's designed for the pavement. When the pavement is designed, it's normally taken for 20 years. So routine maintenance, program maintenance, and then the rehab, and then another cycle goes on. So instead of using very short period for cost analysis, we do go for 50-year, which is a long enough period to come up with the equivalent annual uniform cost. Okay, in the EAUC calculation, there are a number of things we need to know. It's SAR, which is standard axle repetitions, equivalent standard axles. So those things are used in conjunction with the pavement material, and then the model is developed. Now, this relationship between, this graph shows the relationship between SAR and EAUC, equivalent annual uniform cost. The graph was developed by using the various calculation at various stages. For example, -40, -20, +20, +40%, and the line, that line was drawn out. The equation which you can see is y is equal to a plus bx, b being the slope, which is MC, marginal cost. So for each increment of the SAR, standard axle repetition, there is a EAUC increment. So that's what is called marginal cost. The increment as a result of the additional traffic impact due to development activities. Okay, this one just shows the model structures for the life cycle cost analysis, which is incorporated in the FAMIT. So road description, and then the unit traffic loading, and then because of that extra traffic, obviously there is a deterioration, and as a result of the deterioration, the works treatment will be triggered, and what sort of treatment will be done, that will obviously cost money, and all the various treatments are taken into account over the period of 50 years, and then the full analysis is done in order to calculate the EAUC. Now, just going through a little bit more detail, we have more than 33,000 kilometers of road, which includes both sealed and unsealed. Now, we do the deflection survey. It's called TSD, traffic speed by TSD, traffic speed deflectometer. Normally, we do about 20,000 kilometers of road surveyed each year. So currently, we have a little bit more than 17,000 kilometers of the road segments which have TSD data. Sometimes the vehicle cannot go into each road segment, so it's not possible to do full network for each year, and also because of the cost, we don't target the full network for each year, but we do include them in a cyclic basis. Now, the information we need to have is obviously the road functional class and the location detail in terms of the changes, and then the pavement and the surfacing construction, how it is constructed, which is whether granular or asphalt or cement stabilized material. And also we need to know about information about the climate and the soil reactivity. Some soil in the our state road network, they are reactive, some are non-reactive, and also there is also dry reactive and dry wet reactive. Dry, normally 4 types: dry reactive, dry non-reactive, reactive and non-reactive, wet reactive and wet non-reactive. So all those informations are taken into account, and also we look at the pavement or subgrade strength, and also the surface condition, as I said previously, roughness, rutting, and also the associated deterioration for each road segment. The traffic numbers and compositions, we do have our database. We get the traffic info from there, and also we need to know what sort of maintenance treatment is done, and what is the cost for each of those maintenance treatment, whether it is routine, program maintenance, or rehabilitation. Marginal cost calculated based on all physical segments where the deflection data is available, and then by creating representative segments, the remaining physical segments marginal costs were populated using that model, the one I showed you previously. Then we can develop maps illustrating the spatial distribution of marginal cost, and that marginal cost database goes into road link table, and then we develop database tool to calculate pavement impacts for the network where the development work goes on. Now this graph gives you the various impact level in terms of the marginal cost, which is dollar per SAR per kilometer for various road categories, starting from inter-regional to urban sub-arterial. As you can see, the higher effect is on the relatively regional distribution connector road and the rural land access, and also the graph shows the various impact in terms of the different material type, asphalt concrete or cement stabilized or the granular material, the pavement. In the regional and rural road, normally the pavement design, there's more detailed analysis and more weightage given in terms of the design of the urban roads. For example, the roads which have higher traffic, they have the asphalt concrete pavement. So because of that, there is more capacity to resist the traffic impact, whereas the rural roads, the design is fairly simple. Some of the roads don't have pavement design at all, so that's why there's relatively more impact in terms of the marginal cost due to development activities on those road networks. Now this graph shows the marginal cost for different traffic volume, less than 1,500, 15 to 5,000, 5 to 10,000, and greater than 10,000. Again, also depending upon the material type, which is asphalt concrete, cement stabilized, and granular material. So the marginal cost varies depending upon the traffic and the material type, as you can see from the graph. Now this is the model which is used for calculation of the pavement contribution. Now the calculation is done taking into account of the construction period as well as the operation period for each road segment triggered. Now MC prescribed in the it's prescribed in the departmental database for each road segment, which is per SAR per kilometer. Now the length is the length of the road segment, which is taken into consideration for calculation of the pavement contribution, and N is the number of road segments. So a section which is impacted will have a number of road segments. So calculation is done for each road segment because it will have a different pavement material and also can have a different traffic, not necessarily the closed ones, but definitely when you take into consideration of certain kilometer of roads, it will have various types of traffic and the pavement material. This is just an example of the pavement impact assessment, how the marginal cost tool is used. The vehicle has 6 axles with the gross mass load of 4.93 for SAR4, which is the granular and the asphalt concrete, SAR5. and SAR-12, which is the cement stabilized material. 1,000 trips per year over 10 years, and that gives you 10,000 trips all up. The road sections 10A, 10B in the gazetted directions from 0 to 23 kilometer. And also there is a structural, I think this is a structural number. It's related to the structural model. Now, in the next page, you can see how the PIA tool is used. This is as a sample. Let's say there is an overall length of the road, 168 kilometer, broken into road 1 and road 2. In road 1, there is asphalt section, some asphalt section and some cement stabilized. For example, now from 0 to 145 kilometer, 10A, there is 10,000 trips, asphalt section 31.14 kilometer. The marginal cost, the SAR, which comes from the database, for asphalt is 5.61, and now the marginal cost, which is $per SAR per trip, that's also from the our database, TMR database, for each road segment. The cost for entire section is that 0.52 times 10,000 times 5.61. That will give you 29,173 approximately. That's the cost, the total cost. Now, in terms of the same procedure for cement stabilized section, which is 99.27 kilometer, the same method is used. So you can calculate the cost separately for asphalt section and the cement stabilized. So when you combine those two, and then you'll get a total cost for road 1. Now, the road 2, similar method, the 10B 0 to 23 kilometer, similar sort of calculation depending upon different marginal cost from the database and the segments, where they are, what type of material. So once you know the cost for road 2, and then when you combine road 1 and road 2, you'll get the total overall cost, which is that for 168 kilometer, 432,735, and that's the total cost as a result of the impact. Okay, that was a very brief rundown in terms of the seal road, how the model is used and how the calculation is done. So there has been a fair bit of detailed study and analysis, the model development for the seal roads, whereas the unsealed roads, we don't have that detailed tool. We do have obviously a number of unsealed roads, I think roughly about 4,000 kilometers in our road network. Now, in terms of the unsealed road, there is a model, it's called Australian Road Local Deterioration Study, gravel loss model, which has been already developed. That's what is used to calculate the marginal cost for unsealed road. Now, in the next page, I will show you a table. You can see this is the marginal cost matrix for unsealed road. Now on the left-hand side, that's the ADT, average daily traffic, with the percentage of heavy vehicle. And also there's a grading frequency, for example here, that's roughly about 3 times a year. And then what is the initial gravel depth of a particular road segment, starting from 75, 125, 175, 200, so different depth of the gravel. And also there is a material property as well, and the PF and the MMP. PF varies from 50 to 300, that's what is used in this chart. And then the MMP varies from 45 to 100 ITI. So for each initial pavement depth and the specific material type, there is a marginal cost figure. So those costs are obtained based on this particular matrix, and when you add all the cost for all the segments, you get the total impact cost for a particular length of the road we will be interested in. So that's a general sort of model which is already developed and used. But in terms of the shield road, the information I already presented is the one which is used. So that's a very brief rundown for both shield and unsealed road. Please feel free to send your questions if you have anything with regard to this pavement impact study. We'll try to answer as much as we can.